All right, hello class. This is going to be a short video since we did most of the activity in class, but I wanted to kind of summarize what we did when we're dealing with finite geometric series. So series can go on forever and ever and ever, but finite means we're only looking at a particular number of terms of the series. And a little bit different from a geometric sequence because a finite geometric series is the sum of basically a geometric sequence. So as each value in the series is found by adding up so many terms of a geometric sequence. So here we have a geometric sequence that looks like of the form A, which is the initial value, times R, which is the common ratio raised to the I power. And as we can see here, S sub n is calculated by adding up the first n terms of the sequence. Now, I know you're saying, well, why does it end on n minus 1? Well, in this case, they start off with r raised to the 0 power. So it's still n terms. It just starts off with the 0th term, which is the initial term, plus and all the way up to the n minus 1, which is actually in different values or in different terms. And so, of course, I can represent this series by the summation of the geometric sequence representation. So as you can see here, J starts at 0 and goes all the way up to n minus 1. So that is a series of values. So of course, we want to come up, what we worked on last class is we had a lot of different geometric series based off geometric sums. And as n got to infinity, sometimes the sum's limit was a particular number, and sometimes it just went to infinity. If I want to calculate very quickly the sum of a finite geometric series, then there is a formula that we discovered on activity 4, which can be found basically like this: a times the factor 1 minus r to the n over 1 minus r. And to see the proof, we did it in, I think, F period, but we didn't get a chance to do it to E period. So I include the proof. So let's just say we have our S of n, which as we can see here, S of n is equal to a times r to the 0. Highlight this. So this is S of n, this is S of n, as we saw in earlier notes. And let's just consider the expression r times S of n plus a. So here's my r and here's my a. I think I should have made that blue. My bad. So when I multiply each of the terms by r, then the power of the r term increases. So a times r to the 1 plus a times r to the 2, vice versa. And then when I add a, I just rearrange it a little bit and put a from at the end to the beginning. So now I have here this term, which looks very familiar to you guys because that looks exactly like S sub n. And it is. This here, just r is raised to the 0 power. And so I can rewrite this expression of r times S of n plus a as just S of n plus a times r to the n. Well, let's just try and solve for S sub n. So you solve by S sub n. Let's subtract x sub n from both sides, and basically I move things around. So basically, let me change my pen. I move this over here, and I move this over there. Okay, then let's factor out a S sub n. Factor out a S sub n, and so we have here r minus 1. And when I factor out an a, I have a times r to the n minus 1. And then the very last bit is what we end up with in the notes. S of n is equal to a times r to the n minus 1 over r minus 1. We just basically rearranged it, and by multiplying either of these is particularly fine. This is from the form, and this is from the book. And they basically are the exact same thing. We just basically took the opposite. on both sides, on the numerator and denominator. Okay, so that's going to be very helpful. So if I want to figure out the sum of the first n terms of a geometric sequence, all I have to do is take a, which is the initial term, and the common ratio, raise it to the n power, and then perform these calculations here. So either of these are perfectly fine. I suggest you just pick one and memorize it because it's easier to do that as well. Okay, so when you do your activities, you should have no problem in calculating the sum as long as you know what n is, as long as you know what the initial value is, and as long as you know what the common ratio is. All right, that's it. See, nice and quick and easy. So remember, your homework is the first page of that paper I gave you. And then in class on Friday, we will work on the back page.